So this is just going to be a video going through a couple of the questions from that simultaneous equations task on Dr. Frost. I'm just going to upload my written solutions to the other questions, but I'm going to go through 5, 7, 8, 9, 10 or 7, 9, 10. I can't quite remember. I'll see when I go down, because they were the ones that were more interesting and a bit harder. So this one, definitely not a 1-mark question. I think if this was a 1-mark question in an exam, they'd have drawn the lines for you and you literally would have had to write down the coordinate where they touched each other. This would be like a 3 or 4-mark question if it was given exactly like this. So this is a good real-life application of simultaneous equations, where you need to find a coordinate or a point of intersection. You can go ahead and plot the lines and find out where they join. It could be quite time consuming. The whole point of where things intersect and the whole point of simultaneous equations is finding a set of solutions where they are the same, and that is what a point of intersection is. So solving these through simultaneous equations is going to find that point, that coordinate, where they are the same. It's an x and a y value that works for both equations. So my aim here is going to be to get them both to be 6y, because then I know I can start doing my eliminating. So I'm going to do equation 1 times by 2, which is 10x plus 6y equals to 18, and I'm going to do equation 2 times by 3. So that's 21x minus 6y equals to 75. And then we're going to add these together because they are opposite signs. So 31x equals to 93, x equals to 3. I'm then going to sub x equals to 3 into equation... I'm going to go back to the original equation 1. And then that's going to be 15 plus 3y equals to 9. 3y equals to minus 6, so y equals to minus 2. Then I'm going to write my answer out again nicely on the answer line, just so everyone knows it's there. So that's a written solution that you'll see another time. This is probably the one I found the hardest. I think question 9 was meant to be harder, but because this was the first question like this on the sheet, I kind of had a tactic down for question 9 that I was comfortable with. So first of all, I'm going to label my fruits as some algebra letters. So apples is going to be A, banana is going to be B, and oranges I'm going to label as R, not O, because I can imagine later when I write 2O I'm going to think that's 20. So I'm just going to pick R because that's the second letter. You could pick any letter, it doesn't really matter. Then I'm going to write out my equations. So I'm going to have 2 equations from this question, as I've already read it. So 4 apples and 2 oranges equals to £1.54. So I've done that piece of information. Then I'm going to have 2 oranges. I'm going to write it under the oranges just to keep it nice and formatted. And I'm going to have 4 bananas, and that's going to equal £1.70. So right now we can't actually just solve this from eliminating, because we've got 3 unknowns. We would need 3 equations to solve this. It would be a very confusing simultaneous equation method, but it is possible. And if you, let's say you had 4 unknowns, you'd need 4 equations. If you've only got 1 unknown, that's why we just have 1 equation and 2 unknowns. Like we had on the other questions, we start doing simultaneous equations where we have 2 of them, because you need as many equations as you have unknowns to be able to solve. So I'm going to think about this just a bit logically. I'm going to think, well, what is my change in price? Well, my price goes up by 16 pence, or I can call that £0.16. And the only difference in what I've bought is I've bought bananas instead of apples. So I know buying 4 bananas instead of 4 apples has increased my price by 16 pence. So from that, I can figure out that a banana is 4 pence more expensive than an apple. A. I'll show you how we could find that out kind of algebraically if we weren't quite sure on what I've just done there. So I'm going to do equation 2 subtract 1, and that is to eliminate this r. So that's going to be 4b subtract 4a equals to 0.16. So you can see that's where my 16 pence has kind of come from. And then I'm going to divide by 4. So b minus a equals to 0.04. You can see my 4 pence is starting to come into it now. So a banana equals to 0.04 plus a. So a banana equals the cost of an apple plus 4 pence. So a banana is 4 pence more expensive than an apple. The tactic I found most useful for these questions is that instead of having B's, A's and R's, I'm going to try and represent them all in the same letter. So I'm going to say that the price of a banana is X. The price of an apple, you might be tempted, and I made this mistake as well, you might be tempted to say this just because it's there. Think about it logically. If a price of a banana is 8 pence, well, an apple, if it's 4 pence more expensive for a banana, an apple must be 4 pence. So that's actually going to be X subtract 4 pence. I'll just put a cross through that as that's something we don't particularly need at the moment. So I've got my banana and my apple. Let's go figure out an orange. So I'm going to go back to equation 2. So I'm going to sub that b equals to x in there. So 4x plus 2r equals to 1.70. So 2r equals to £1.70, subtract 4x, and then I'm going to divide by 2 to get r equals to this. So that is my value of r. It's 85 pence minus the cost of 2 bananas. That's what that means. So what I want to find out is an apple plus a banana plus an orange. That is kind of my aim of the question, isn't it? And I've got these all in terms of x. So an apple is going to be x minus 0.04 plus a banana, which is going to be x, plus an orange, which is going to be 0.85 minus 2x. Okay, so let's collect my terms with the x's. I've got x, 2x, subtract 2x, so that's no x's. And then I've got 85 pence, subtract 4 pence. So that is 0.81 or 81 pence. So the cost of getting a apple, banana and an orange is 81 pence. Very confusing question, but that's why it's a maths challenge question, because they like to be hard and confusing. And I think it's better to kind of figure out and practice how to do it this way than to trial and error, because you'd be there all day. Okay, another math challenge question. Not nearly as hard, I don't think. It's just testing your knowledge of all the words. So a sum of 2 integers. I'm going to say that that's a and b. So a plus b equals to 97. The difference, well, we can say a minus b, we can say b minus a. It depends what we're classing as our bigger number. I'm going to say b is the larger number. So I'm going to say... Actually, no. I'm going to say a is the larger number. So a minus b would give us the positive number of 37. I can then add these to eliminate my b. So 2a equals to, well, what's 97 plus 37? I've got this written down. 134. So divide that by 2. A is going to be 67. So let's go back in and think, well, what is our answer to this? Sub it back into, that was equation 2, sorry. So let's sub A equals to 67 into 1. 67 plus B equals to 97, pretty easy, B equals to 30. Then wants us to find the product. Well, that's just A times B. So 67 times 30, that gets me 2010. Okay, this was another one of these weird questions. So I'm just going to call these by their alphabetical names, and let's just write out the equation. So altogether, they have £150, so I can write that out easily. So I'm done with this information. Al and Bertie, so A and B, have £55 between them, so I'm done with that. Al and Chris have £65 between them. You don't have to write it out like I am. For some reason I'm just thinking it's nice to keep them all in a column. What is the difference between Al and Dave? So we want to find either Dave subtract Al or Al subtract Dave. It depends on who has the larger amount of money. If we do it the wrong way around, we'll just get the negative version of it. But we'll be able to, I'll talk through that at the end. Well, I can make up some new equations with this. I can take this AB equals to 55 and put it here. So let's do that. Let's put 2 into 1. Well, that's going to get me 55 plus C plus D equals 150. So that's going to get me C plus D equals 295. And I'm going to keep that for now. Probably call that equation 4. And then I'm also going to put 3 into 1. So the A and C I'm going to take them out and put 65 in their place. So 65 plus B plus D equals 250. So B plus D equals 285. I'm going to call that equation 5 just for now. And I'm going to put a little square around that. So right now, I've got B plus D equals to 85, and I've got C plus D equals to 95. You can see I've set up a nice simultaneous equation here, where I can do a subtraction to eliminate D. So C minus B equals to 10. Now, we've got to go back and do our whole thing of labeling everything to be with X. So I know that what's this guy called? Chris has the amount of money that Bertie does plus £10. So if Chris has X amount of pounds, Bertie must have £10 less because Chris has £10 more. So that's going to be X minus 10 for Bertie. We then need to go and figure out, well, what is this for the other lot? So I'm going to use this equations of A plus C and maybe C plus D or something like that to find out, I want to find out what C is in terms of X. And you can probably use any equation you've got. Oh no, I've already got what C is in terms of X. I want to find out what A is in terms of X. So I'm going to use equation 2. That is A plus X minus 10 equals to 55. So A equals to 65 subtract X. That's just adding the 10 to the other side, taking the X to the other side. Now I want to find D in terms of X. So let's take an equation with D in it. I've got this C plus D equals 95. So I'm going to use equation 4. So that C is X, so X plus D equals 95. So D equals to 95 subtract X. You see, this is quite a confusing question, but I am just following a process that I kind of laid out in the question 7, or whatever it was, 7, yeah. So, now I want to do this. I've got my D, I've got my A. Let's do just do the first subtraction. Let's just do d minus a. So 95 subtract x, that's d. And 65 subtract x. You're going to have to be careful with your brackets. Remember this whole thing. So I'll write it out again. 95 minus x equals to minus 65. Oh, not equals to, sorry. This bracket here will equal to minus 65. When we expand this minus lots of minus x, that is plus x. Can you see how my x's can cancel out now? And I'm left with 95, take away 65, which is £30. If you were to do a minus d, you'd have got minus £30, and you'd have just had to realise, well, I've just done the smaller number, subtract the bigger number. So all I can do is just change the negative sign to a positive £30. Horrible question, but it is intermediate math challenge. It's question 16. That's where you start losing marks. So you did that this year. You'll know how hard them questions can be. And then our final one, not as bad. This is a GCSE style question, difficult GCSE question, but not nearly as bad as that math challenge one. Dan drives two routes. He drives x and y. He drives so equation route 1 will be he does 3 lots of route x and 2 lots of route y, and in total he drives 134 miles. Equation 2, he does route x twice and route y 5 times for some reason, and he drives 203 miles. My objective here is probably going to be to get 6x. So I'm going to do equation 1 times by 2. That gets me 6x plus, that's wrong, plus 4y. I'm going to change these to lowercase just because it's easier for me to write. And that equals to 268. And then I'm going to do equation 2 times by 3. That gets me 6x plus 15y equals to 609. I'm then going to do, I'm going to call this equation 3 and 4. I'm going to do equation 4 subtract equation 3. And the reason I'm doing that is because these are the bigger numbers. I would normally write them out again. So I'll do that just for the sake of it. So I would write it out again, just to make sure I'm making no mistakes. And if I do make mistakes, the examiner can see my working out and can award me the majority of the marks for my method. So I'm going to subtract these. That's going to be 11y. This is going to be 341. We're going to find out y equals to 31. And then I'm going to sub y equals to 31 into, let's go equation 1, seems the easiest one to put y into, 3x plus 62 equals 134. 3x equals to 72 and x equals to 24. So again, write out your answer. My answer line's on the page below. I'm not going to scroll down. Write out your answer. And there we go, that's all the questions. Thank you for sticking around. That's quite a long one, I think. No, not too bad. Alright, thank you.